All right, how you doing, Zach? I'm going to go through those two that you asked me about. Hopefully, this is useful for you. So this is normal calculations in reverse. What you got to understand here is you got that table that you're looking at. I wonder if I can pull one up. The numbers on the inside of the table are percentages. So this is what I want here. So all these numbers in here are percents. So like right here, let's say for example, that means 23.885% of the data is lower than a z-score of negative 0.71. So how that works for this one, we got a couple things going on. We got mu here, we got sigma there, and then they say, okay, what about the top 5%? Well, the top 5% means we want 5% of the data to be up there. But that table only thinks in terms of lower. So the table will take whatever z-score you give it and tell you the percent of data that is to the left of it. So I want this, but to find this z-score, I can't look up, hey, what is 5% bigger than? I have to look up where is there 95% of the area below, and that's going to be the same spot. So I'm going to try to find 0.95 inside this table somewhere as close as I can. So I see right here 0.9495 and 0.9. So 0.95 is basically right here. So I've got 1.65 is my z-score. And then once you know that, you have your formula. So you know, oops, I can't write there. You got z equals x bar minus mu. This is super awesome handwriting, I know. But now I can go 1.65 equals x bar minus 66,000 divided by 22,000 and solve this. So what you would do to solve this, and I'm going to stop writing at this point, but you're going to multiply both sides by 22,000, and then you would add the 66,000 to both sides. I'm going to guess that's maybe this one, maybe this one. So I'm just going to the next one to see if they're kind of the same deal, and they are. So again, you have the mean, standard deviation, and the lower 50% of scores. So if I want to look that one up, and that one's a little kind of a goofy one, jeez. But if I want to know where 50% of the scores is below, that's actually a z-score of 0. We could probably see that in the table too, but yeah, 0, that means you're 0 standard deviations away from the middle, so you are right in the middle, and that's going to be 50% of the data. So my guess is all of these are the same. The people that have had questions on these, they've kind of showed me all the similar problems. So this one looks the same too. You got your mean, your standard deviation. This is 25%, but it's the top, so you're going to look up 0.75 in that table and go from there. Let me look back and see what the other. So area under density curves. Let's see. All right, let me go back to my area right there. All right. So what you want here, percent of the area, what you want is the area you're looking for. So let's say like area targeted. Divided by the total area. But the nice thing about these is a density curve means it represents all of the possibilities, and therefore the total area under all of these is 1. And your job is to find like what percent of the area is less than 2. So right here, we're basically finding like out of this whole shape here, what percentage of it is right there. So it's kind of like a geometry problem, really. I want to find like I said, you want to find the area of the whole thing, but that's going to be 1 every time. So really what I want to do is just find this. So I'm going to look at this one like, okay, I've got a rectangle here with a base of 1 and this would be a height of 0.25. You know, like this would be 0.5. So this is a rectangle with a base of 1 and a height of 0.25. So that area there is 0.25. And then this is half that. So this is going to be 0.125. And if I add up those two, 0.375, so 37.5%. So similar thing here. You want the area that we're looking for goes on top, and the total area goes on the bottom, but the total area is always 1 in a density curve. So your job is to find the area of this part of the triangle, more than 3. So the area of a triangle is 1/2 base times height. The base of this one's 2. The height of this one is 0.4. And if you multiply those together, you would get 0.4. So that's 40%. And there you go. Less than 4 here. I think you're probably getting the idea, but hopefully you could look at this and say, okay, yeah, 3/4 of that. So the whole thing is 1. And I'm being asked for 3/4 of it. So this is going to be 75%. So I'm going to stop this and upload it and send it to you, and